Morning, guys. A lot of you guys have been asking about connecting the rate of change, the slope of a graph, and the intercept, the y-intercept, and the initial value, and using that information to write the equation of the line, and then using that equation to calculate different values. I want to try to give you an example of that today. So what I have is a vase with some water in it, and my goal is to use these marbles to raise the level of the water up right to the very top of the vase without going over. I don't want to spill water on my laptop. So I want to go right to the top, but not go over. Okay, so first of all, I want to collect a few data points and find out if I think this is a linear relationship or not. I mean, if it's not a linear relationship, then all the math that we have is not going to work, right? It is, but let's just make sure. Okay, so first I'm going to think about how to collect my data. There's a couple of different ways that I could measure the water level in this vase. I could try to measure from the bottom of the water. There's about an inch or so of glass before you start getting water. So I could measure from that and go up to the water, but the problem is I might not put my ruler in the same place every time. I could go from the top down to the top of the water level, and that's probably a good way to measure. In that case, I would think every time I dropped a marble in, that value would be getting a little bit smaller, right? So it would be a decreasing relationship, and I'd be looking for how many marbles to make the y value in my relationship 0. That's not a bad way to measure this. I'm going to use a slightly different approach. I'm just going to put my ruler on the table, right? Because then I can repeat that exactly the same every time. And I'm going to measure the height of the water. So my initial value, the height of the water right now with no marbles in it, is about 14 point, hard to see there. Looks like 14.7 centimeters. Okay, so I'm going to record that into a table of values using Desmos. So 0 marbles, 14.7 centimeters. All right, now I'm going to put a couple of marbles in, measure again, put a couple of marbles in, measure again, put a couple of marbles in, measure again, and see how linear the data looks to me. If it's a good linear fit, awesome. If it's not a good linear fit, I might need to use some different math. So I'm just going to add a bunch of marbles at a time, say maybe 5, right? So 1, 2, 3, 4, 5. Okay, now let's measure the water level again. And I get 15.4 centimeters. So 5 marbles, 15.4 centimeters. Okay, now that would be enough information. If I was sure this was linear, that would be enough information to calculate the rate of change already. I could figure out how much does the water level go up for each marble, right? So I would just take the difference in water level divided by 5 because I put in 5 marbles, and that would be how much does it change per marble. That would be the slope or rate of change. Not 100% convinced about this being a linear relationship, so I'm just going to do that a couple more times, speed the video up, take the measurements, and we'll see what we come out with. Okay, I'm going to cut over in the video over to my Desmos screen so that you can see what's going on there. Okay, you can see that I've collected a nice bunch of data. With 0 marbles, it was at 14.7 centimeters, 5 marbles, 15.4, 10 marbles, it went up to 16, 15 to 16.7. So you can see those points are lining up in a real nice straight line. Let me just zoom to the data here. That looks great. Okay, I could figure out the rate of change per marble basically by taking the first point and the last point and figuring out the rise and the run between them. and then dividing that. So I could figure out the slope is equal to the y value from the last point, so 17.4, minus the y value from the first point, 14.7. That would be the rise. So right now you can see Desmos is telling me the rise is 2.7 centimeters. And I did that with 20 marbles, but technically it would be the second x value, 20 marbles, minus the first x value, which is 0 marbles. And you can see that Desmos is telling me that looks like a rate of change per marble of 0.135 centimeters, or like about just under 1.5 millimeters raise in water level per marble that I add. Okay, so now I want to try to write an equation for the height of the water depending on how many marbles I've dropped into it. So I would say right now I'm using y as the height of the variable for the height of the water. So y is equal to 0.135 times how many marbles I dropped in, because every marble adds 0.135 centimeters to the height of the water. But then I didn't start at a height of 0. I started at a height of 14.7. And look at that. There's the line, and it looks like it's going almost through dead center through all those points. Okay, why doesn't every single point line up exactly on the line? Those marbles are not perfectly formed, right? Not every single marble is exactly the same size. So there's a little bit of natural variation, but they're real close to each other, and that's why every point is real close to the line. So I should be able to get a pretty good calculation here to figure out how many marbles I can drop in to make exactly the right height. All right, I want the height to be 22.5 centimeters. Now I just need to zoom this graph out a little bit so we can see, okay, there's that line that I need, 22.5 centimeters tall. Well, what happened there? And if I look for the place where those two lines meet, right there, what Desmos is telling me is that if I put in 57.7 marbles, that I should get the water to be at exactly the right height. Okay, now I can't put in 57.7 marbles, so I'm going to try to put in 57 marbles, and we should be just a tiny little bit under the top of the vase, and then I'll put in that 58th one, and that'll probably spill over by just a little bit. Okay, so let's give that a shot. Now remember, I've got 20 marbles in here right now, so I'm going to add another 37 marbles, and that should bring the water right close to the top. All right, here we go. 2, 4, 6, 8. There's 10. Not nervous yet. I'm getting nervous around 35. 2, 4, 6, 8. That's 20. Okay, starting to get a little closer here. 2, 4, 6, 8. There's the 30. That's getting real close. Okay, 7 more I'm supposed to be able to add. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, I dropped that pretty hard, but it did spill a little bit. And then here's the 7th one. That's about as close as you can get to the top of that vase. Yeah, I did go over a little bit, but I came up with a pretty good equation for how many to add. Now it's supposed to be 57.7, so like, here's a broken marble, let's call that 1.7. It's obviously gonna spill out, but it was fun anyway. It was fun to put together the equation. It was fun to come up with the number, and it was nice to see how closely the math actually worked out. Remember, it doesn't work out perfectly because of natural variation in the size of the marbles. Okay, it works out really close because they're well formed, but not perfect.